So if you remember when we initially solve quadratics, the first thing we do is we find the discriminant. And if you remember, right, we said if the discriminant is equal to 0, the quadratic would have one solution. If it's equal to a positive number, it would have two solutions. But now what happens? What happens if the discriminant is equal to a negative number, right? What would happen to that? Well, technically we get no solution, but we're going to change it now to two imaginary solutions, okay? So if you remember how we solved quadratics, first thing we're going to do, set it equals 0 and find the discriminant. So the discriminant, we use b squared minus 4ac. So in this case, negative 4 squared minus 4 times 1 times c is 7. So that's going to give you 16 minus 28, which would be negative 12. So right away there, this tells us we're going to have two imaginary solutions. But how do we write our final answer? Well, what we're going to do is plug it into the quadratic formula using the opposite of b plus or minus the square root of the discriminant all over 2a. So if b is negative 4, the opposite of negative 4 is 4 plus or minus the square root of negative 12 all over 2 times 1. But when we simplify this now, we're going to get 4 plus or minus the square root of negative 12. It's going to be the square root of negative 1 times the square root of 4 times the square root of 3. That will become 4 plus or minus 2i root 3 all over 2. But now what I notice is all of these numbers can be divided by 2. When I divide everything by 2, I end up with 2 plus or minus I root 3. Okay, I know this is not easy seeing it the first time around. All right, so let's do another example. So the next one, we go ahead and we find the discriminant. So 14 squared minus 4 times 1 times 51. And when we simplify that, 14 squared minus 4 times 1 times 51, we get negative 8. So right there, because that's negative, we know we're going to get two imaginary solutions. So we get x equals the opposite of b. So if b is 14, we're going to get negative 14 plus or minus the square root of negative 8 all over 2 times 1. And now, when we simplify the square root of negative 8, that would give us the square root of negative 1 times the square root of 4 times the square root of 2. This would give us 2i root 2. So, negative 14 plus or minus 2i root 2 all over 2. And now, what can I divide all of these numbers by? I can divide them all by 2 again. And when I do that, I get negative 7 plus or minus I root 2. And you would leave your answer like that. Okay? Here we go with another one. Discriminant. So negative 10 squared minus 4 times a is 1 times c is 19. When I do that in the calculator, you get 24. Now, because this is a positive number, we're going to get two real solutions. So x equals the opposite of b is 10 plus or minus the square root of 24 all over 2 times 1. So here you'd get 10 plus or minus the square root of 24 breaks up into root 4 times root 6. So that's going to be 2 root 6 all over 2. And again, all of these outside numbers can be divided by 2. So we would get 5 plus or minus the square root of 6. And the last one, find the discriminant. So we get 7 squared minus 4 times a is 3 times c is negative 20. So right away we get 49 minus 4 times 3 times negative 20, and you get 289. That tells us we would get 2 real solutions, and that would be negative 7 plus or minus the square root of 289 all over 2 times 3. Now, you have to understand the square root of 289 is a perfect square, so this is going to be negative 7 plus or minus the square root of 289 is 17 all over 6. Now we can break this up into two problems. Negative 7 plus 17 all divided by 6. That'll give you 10 over 6, which reduces to 5/3. So that's one solution. The other one is negative 7 minus 17 divided by 6, which gives you negative 24 over 6, which is negative 4. Okay, so this is a refresher of solving quadratics, which you guys actually did a pretty good job on. So now we're just adding a little element to it. I will be there on Tuesday to answer any questions. Good luck.